Welcome to This Explainer. Today, we're doing something honestly kind of magical. We're going to take the raw, messy chaos of numbers and transform them into crystal clear, actionable business strategies. Just imagine a screen full of swirling, totally random numbers. Our job today? Capture them and snap them into perfect focus.
To kick things off, ask yourself this. What's the actual difference between meaningless noise and a brilliant business strategy? When you're staring at thousands of login records or test scores, how do we actually find the hidden patterns in that sea of random data? Well, the answer, of course, is statistics.
All right, let's look at our roadmap. We'll hit 6 key milestones today. First up, what is business statistics? Then 2, organizing the raw chaos. Followed by 3, scaling and classifying data. 4, visualizing the data story. 5, the area principle rule. And we'll wrap it up with 6 key takeaways. Let's see exactly how data transforms from messy inputs to split-second decisions.
Okay, jumping right into Section 1, what is business statistics? The absolute foundation of data.
So, simply put, statistics is the process of collecting, organizing, analyzing, and drawing inferences from data. It's basically an assembly line for information. And hey, this isn't some new tech-age fad, right? From ancient Egyptians tracking crops to modern stock market analysis, statistics has always been our ultimate tool for making sense of the world. It really boils down to the 3 pillars of statistics. First, we have descriptive, which is just summarizing data to see what already happened. Next up is inferential, where we analyze and extract insights to figure out why it happened. And finally, predictive, where we build models for upcoming events to forecast what happens next. So it's describe what happened, infer why, and predict what's next.
Easy, right?
Moving right along to Section 2, organizing the raw chaos. Basically, structuring the noise.
Think of organizing data like cleaning out a super messy closet. Watch how everything just snaps into a nice grid here. We sort these student marks using rows for individual observations. So you see Ram, Rahem, and Rosberg. Then we use columns for attributes or what we call variables, like financial accounting or management. Just like that, total chaos turns into a rigid, easily scannable structure.
That naturally brings us to Section 3, scaling and classifying data. This is all about giving our numbers actual meaning.
Because, you see, not all variables are created equal. Quantitative data splits into 2 paths. We've got the discrete variable, which means specific, countable values. Think of it like a light switch. It's just on or off, like counting the exact number of students in a room. Then we have the continuous variable, which covers infinite values between 2 points. It's more like a dimmer switch, sliding smoothly up and down, kind of like measuring temperature.
And that leads into how measurement scales build up in complexity, layer by layer. Step 1 is nominal, just naming categories like gender. Step 2 is ordinal, adding ordered categories like rank, first, second, third. Step 3 is interval, where we have equal gaps but no true zero, like temperature. And finally, Step 4 is ratio. This is the top tier, where an absolute zero actually exists, like income. Zero income literally means $0.
We can even bridge the gap between squishy human feelings and hard math using a Likert scale. Imagine looking at an app review. This scale takes those ordinal feelings, from a 1 meaning very bad, up to a 5 being the best, and converts them right into numerical data. We literally translate human emotion into a format we can actually analyze. Pretty cool. Okay, now for the really fun part. Section 4, visualizing the data story, or painting with numbers.
Think of data visualization in business as a dashboard for the driver to make split-second decisions. When you're driving a Formula 1 car at 200 miles per hour, you definitely don't have time to read a giant spreadsheet. Good visuals convert raw inputs into a clear, instant dashboard.
Take a classic bar chart, for example. We instantly see our categorical variables on the x-axis, like the hometowns Chennai, Mumbai, or Secunderabad. Then the login counts shoot up the y-axis. In a fraction of a second, without reading a single row of text, it reveals exactly which hometowns are logging in the most. It's instant visual translation. But watch this trick. If we take those exact same bars and sort them from highest to lowest, it becomes a Pareto chart. And suddenly, boom, a whole new narrative emerges. The Pareto chart shows us that just a few locations, Chennai, Secunderabad, and Mumbai, are driving the vast majority of traffic. It instantly isolates the vital few from the trivial many. Now, if we want to look at parts of a whole, say student placements across different industries, a donut chart is your best friend.
It displays numerical proportions as slices. The second you look at it, it highlights that consulting, sitting at 56.4%, is taking up way more than half the pie.
But hey, before we get too carried away, let's hit Section 5, the Area Principle Rule. This is all about keeping charts honest.
Visuals are incredibly powerful, but they have to follow a golden rule called the area principle. This dictates that the area of a shape in a visual representation absolutely must be exactly proportional to the value it represents. If the number is twice as big, the ink on the page better be exactly twice as big.
And you know what's wild? How often charts violate this exact principle just to grab your attention. Look at this example about Bush tax cuts expiring. The visual jump looks massive, right? But hold on, look at the y-axis. It starts at 34 instead of 0. By chopping off the bottom of the graph, it wildly exaggerates a tiny increase, completely distorting reality. Always check your axes.
To make sure we aren't fooled by deceptive graphics, we rely on the central tendencies to find our data's true center. We've got the mode, which is the highest frequency or the longest bar, the median, which is the exact middle observation in ordinal data, and the mean, which is just the true mathematical average of all values. These three anchors keep us grounded in reality.
And that brings us to our final stop, Section 6, Key Takeaways, wrapping up our data journey today.
Let's summarize this entire concept into 3 simple sentences. First, statistics is the engine that turns random noise into organized data tables. Second, data is scaled upward from simple naming categories to absolute measurable ratios. And third, visuals absolutely must follow the area principle to honestly and accurately guide split-second decisions.
So, I'll leave you with this final thought as we close out today's explainer. In your own career and on your own dashboard, are you letting random noise dictate your choices, or are you ready to let the data drive?